Okay, so what we're going to do now is we're going to set up a vision project for the Fanuc robot. The first thing we need to do is go into Microsoft Internet Explorer, and we need to log into the robot controller, 192.168.1.50. We should get this screen here. We need to click on Vision Setup, and it opens up this screen. If this isn't the screen you're getting, it's because you probably have some kind of communication stuff that you still need to set up, and you can refer back to my first video to do that. So when we go into this screen here, we have a couple of different options. Minimize some of this other stuff. The main thing that we're looking at right now is this button right here. It's called V-Type. And when we click on that, we have a couple of options here for camera setup tools, camera calibration tools, vision process tools, and application setup tools. What we're going to use are these first three options. The first thing we're going to do is set up the camera for our system. And when I click on that, it actually doesn't change anything because that's already where I was. But I'm going to click the Create button, and I'm going to create a new camera setup for this particular project. We don't have to do this all the time. For instance, if we have a robot and we're creating a number of different vision projects for it, we really only need to set up one camera for all of those different vision projects. You guys are all going to create your own camera setup so that you can go through here and do this individually for yourselves. But if we were doing this for a company or for production, we could set up one camera and use it for all of our different vision projects. When we go in here, it asks me what kind of camera we're using. We are using the Sony analog camera. So I can just select that, and I'm going to give it a name, Brandon's camera. And then I can give it a comment if I want. I'm just going to say, example camera setup. So when I do that, I can click on OK, and I have my camera set up here. I can double click on it, and I can actually see an image of what the camera is looking at right now, which is nothing really. If I click Snapshot, I can get a snapshot of what the camera is seeing. If I click Live, I can get a live view of what the camera is seeing. So the next thing I need to do is I'm going to go back in to this camera that I had set up here. And what we can see is basically a snapshot of what the camera's looking at. And I can go and click Live View, and I can see a live view of what my camera is looking at. And again, kind of test to make sure it's working. But we have a couple of different settings over here, one of which is our exposure time. And I can manipulate that a little bit and see if we can get a little bit better picture. So when I go down, when I go up with it, it looks like I'm getting a little bit brighter image. So I'm going to leave it at that, 75 milliseconds. The thing that we want to keep in mind is that when I adjust that exposure time, the higher up I go, the more time it takes to do each snapshot that the camera is going to do. So if we're trying to have a very fast process here, having a real high exposure time might actually cost us some of the time in our cycle time and time to take a picture each time. So I can check and do a snapshot, and I can do a live view, and I can see that my camera is seeing a pretty decent image here. So what I'm going to do is click Save, and I'm actually going to jog the robot up a little bit because I'm so close to the table that I'm not getting a very good view of everything. So jog the robot up. And I can do a live view while I do this and see what the camera is seeing and see how much of the table that the camera sees. So I think this is about where I want my camera looking when I'm doing this. So I'm going to hit stop on my live image, and what I'm going to do next is I'm going to select which one of these cards I'm going to use for my camera calibration. And what you can see is they all kind of look the same except different sizes, all the way up to our biggest ones here. And we need to figure out which one of these is going to be really the biggest one we can use and still see it inside the camera's image here. So if I put this down, I can sort of see whether or not I can use the bigger one or if I need to use the smaller one. We have to get the entire thing inside the robot's field of view. So I'm going to use this one, which is the second to biggest one. I'm going to set it right there. What you can see, there's a couple of things on each one of these cards that we need to take note of. First of all, it tells us what the size of the grid spacing is. This one here, the biggest one, is 30 millimeters. And the one we're going to use is actually 22.5 millimeters, and that's the millimeters from each dot, from center to center on each dot. We also have an indication of where our X and our Y are aligned for when we do our custom user frame that goes with this. So we don't have to align the X positive and Y positive to our robot's current X and Y axis, because we're going to be able to take care of that when we build our custom user frame. We're going to be able to set it up to use whichever way we need to use it. So right now, I actually do have my X and my Y somewhat aligned to the X and Y of the robot's field of view, or the robot's world frame. But it doesn't have to be like that. What I am going to do, now that I have my grid selected, is I'm going to tape it down temporarily. Because once we start doing what we do here, we don't want that to move. And I think I'm also going to try to change that exposure time a little bit, because it's still pretty dark. That looks a little bit better. And we don't have very good lighting above this robot. One of the things with Vision System is they're very sensitive to what type of lighting we're using above the robot for us to view the camera image. Fluorescent bulbs, like the ones that we normally see in our classroom, are very, very bad for what we're doing, because fluorescent bulbs just flicker. They flicker at an extremely high rate, which we don't really see as humans, but the camera picks it up real well. And that type of stuff is not going to be good for us snapping images of our objects. The best thing to do is to use some kind of LED lighting, because the LED lighting does not flicker. It's a constant stream of light. So I think this is pretty good here. I can adjust the focus on my camera it's got some dials on here that will allow me to dial it in and focus it a little bit. Let's see if we can get it real good. That's probably as good as I'm going to get it. There are a couple of set screws on the dials of that camera so that once we get it lined up with the, once we get it focused, I guess, we can screw those down and keep that focus. So another thing I'm going to go ahead and do right now is I'm going to set up a couple of positions, and I'm going to use position registers because it's easy to do it with position registers for what I'm trying to do here. But we need a couple of different positions, and we can set them up ahead of time. First of all, we need a position that the robot is going to go to every time it takes a snapshot. Because part of what's going to make this system work is that the camera has to be in exactly the same place every time it takes a picture. If the camera is not in the same place, then the targeting software is not going to be able to do what it does. So I'm going to record a position that I'm at right now, and I'm going to call that my camera position, or my picture position. Once I've got that saved, I'm actually going to go ahead and create two more positions. I'm going to create one for my pick and one for my place. I'm sorry, not pick and place. I'm going to create a position for my pick, and I'm going to go ahead and create a position for my hover also. And I'm going to come back and record those positions later, but I'm going to go ahead and get them in there and get them named right now. So I've got a position saved for where my camera is going to be at whenever I take a picture. And now I've got a position saved for my pick and my hover, although those are not yet recorded as positions. I just have them named and ready to go. So once I do that, and my camera's focused, I'm going to stop the live view. Zoomed out or something. Okay, so end edit. And then I usually like to go back in there and make sure all my values saved. I'm at 150 milliseconds for my exposure time now. So end edit. The next thing we need to do is we need to calibrate the camera to this card that we're using with the dots on it, the grid they call it. So I'm going to go to my camera calibration tools, and I don't have any set up yet since this robot's never been used for vision. So I'm going to have to hit create. I'm going to call it my grid calibration, my grid pattern calibration. I give it a name, and I'm going to call it Brandon's calibration. Brandon Calib. And then I'm going to comment that it's an example camera calibration. Once I do that, I click OK. And now it pops up on my screen, and I can double click it and go in there. The first thing I need to do is take a snapshot. and it says there's no camera setup selected. So click OK. Over here, where we have all of our options, this is where we're going to set everything up. The first thing I need to do is I need to tell it what camera system, from the cameras I have currently created on this system, which one am I going to use. And I'm going to tell it Brandon camera. And then I'm going to take a snapshot, if it'll let me. Right here, it gives me another place to type in my exposure time. For whatever reason, it's not using the exposure time that we had set up with our camera. It's probably internal into this setup tool where we can specify that. I think we had 150 on the last one, so if I click on that, my image gets a little bit brighter, and we're going to use that. The next one it has is our grid spacing, and it's defaulted to 15 millimeters. That's not the grid spacing for the card that I have selected, because it gives me about 6 different grid calibration cards. The one we're using is 22.5 millimeters. So I need to make sure that I type in 22.5 millimeters on that grid spacing, because otherwise my calibration is going to be totally out of whack. The number of planes, we're going to use one robot held camera grid. No, there are ways that we can set up more and more advanced vision systems. For instance, the robot's holding the grid and the camera is stationary. That's not what we're doing here. What we have is the grid itself is stationary and the robot's holding the camera. So robot held calibration grid, no. Calibration grid frame. We have not created one yet, so we cannot complete this setup until I've created my custom user frame to go with this. My projection, we're going to select orthogonal. The perspective projection is for when we're dealing with 3D vision, and we're not dealing with that here. Everything we're going to do is in 2 dimensions. So I'm going to select my projection type as orthogonal. And then what I'm going to do is I'm actually going to save, and it's time to create my custom user frame before I can continue. And for that we have to do that inside the robot teach pendant. I'm going to video some close-up for this. And the way to do this is just like when you guys have done your own custom user frames in the past. We need to go to our frames. And right now it wants a tool frame. I'm not going to do that. I want a user frame. And I'm going to create one detail. I'm going to call it my I guess Brandon's user frame. Okay, so once I go in there, I have to save my 3 positions that are required to do a user frame. Let me have one of those cards. Let me have the big one. One thing that's important is that you don't ever bend one of these cards, because you need it to be perfectly flat. In fact, they actually have a sticky material if we wanted to create something where we can stick it down permanently. But when I do this user frame, I'll hold it like that. I'm going to start my origin point of my user frame on this big dot in the center of my grid calibration. My X direction, I'm going to move up here, and we have our X indicator on the card itself, but I'm going to move up here to this dot straight up from the center, and I'm going to save that for my X position, and then I'm going to go back to my origin, and I'm going to come over here and save this one for my Y position in the same direction that it shows for my Y. So I'm going to do the center point, and then my X, and then my Y, and that should give me a good user frame for what we're doing. So to do that, it's basically just jogging the robot as we've done when we did our other user frames. One thing I'm going to do is I'm not going to go all the way down to where my suction cup is touching the card, because it's very important that I don't move this card. And in fact, I don't need my frame to be right on the card itself, because I can always adjust my Z positions very easily later on with the way we normally adjust our Z. So I'm going to say I'm probably about ½ an inch off of that card. And here's my right hand rule, positive Y. Essentially what I do is I try to line it up. I can look down the line of those dots, and I can basically just eyeball it and see whether or not my tool is centered on that center line of dots. So that's the first thing I'm going to do. And then if I come over to this side, I can see the other direction. Alright, so I think I'm in the center of my origin, so I'm going to record that location. Now I'm going to go in my plus X direction, but what I'm really concerned with is that I get it centered over that dot that I indicated earlier. That is going to be my X direction. We can mount this card diagonally or sort of offset. It doesn't matter. I'm not trying to match up my user frame with the world frame. What I'm trying to do is create a user frame that's exactly perpendicular and square to what the grid on this card. And that looks pretty good for my X, so I'll record that one. I'm actually going to use the Move To feature to go back to my origin, and then I'm going to move to my Y position. Looks pretty good. Good, so I'll record my Y position here. Alright, so I have created a user frame. We want to remember and notice what user frame number we've created, because this one is user frame 2. And now, when I go back to this program, I need to tell it that I'm using user frame number 2. So again, I have my exposure time set up where I have a good level of brightness here. I told it what size grid spacing we're using depending on the card that we chose. No, it's not a robot held calibration grid. I am using calibration grid user frame 2, orthogonal type of projection, and then I can hit my snapshot. That's not going to work. The first thing I need to do is move my robot back to that position I saved earlier, my camera, my picture position. So I'm going to do a Move To on that. Okay, so my camera's back in the right position. I need to take a snapshot. And then what I can do is set my fixture position and do a find. And when I hit the find button, it brings up this window that lets me sort of customize the viewing size of the image. And I don't really have to shrink it down, but I'm going to. And you can see that my grid calibration square is not really perfectly aligned to what the camera is seeing right now. That's okay, because it's going to find the center of all of those dots. And this is what gives me my calibration. Once I do that, I'm actually going to click the set button again just to make sure that everything is good. And find again, calibration data was recalculated. You probably don't need to do that. I just like to do it because I like to be sure. Once I have that, my camera is calibrated. The camera knows the distance between each one of those dots, so it's able to run some kind of calibration, and essentially it's overlaying what it finds on these dots to the user frame that I've created using this center point as my origin. So now my user frame and my camera both have a correlation to each other that allows the robot to take a picture and know what the position of the robot actually needs to be at. So I definitely want to save that, and I can end edit. Now that I've got my user frame set up, and I've got my camera calibrated properly, I can remove this card. I shouldn't need this anymore. The next thing we're going to do is we're going to go back to V-Type. And we're going to select Vision Process Tools this time. When I go to Vision Process Tools, again, none have been created so far. And since none of them have been created so far, I need to create my own. It asks what type. We're going to do a single two-dimensional view vision process. I'm going to call it Brandon's process. And on my comment, I'm going to say example camera process. And when I've got that, I click OK. Now we see this in our list of processes. I can double click it to go in there. We have a number of things that we have to set up on this screen, just like on the last one we did. First of all, I need to tell it what camera calibration we're using. I just finished creating one. So I'm going to select Brandon Calibration. Again, it wants me to select my exposure time, and we know that we've been using 150 for that exposure time. So I'm going to go ahead and type that in. And we've got a different image now. We've got our brightened up image. I'm not going to mess with the multi-exposures. I'm just going to leave it at 1. Number defined, I'm going to leave that at 1. Offset mode. We're going to use a fixed frame offset. My offset frame, that's the frame we created a couple of minutes ago, so I'm going to select frame number 2. Unfortunately, it doesn't give me the names of my frames. I can only see that when I go into the teach pendant and look at it. But we know that we're using user frame number 2 for this stuff. I'm not going to mess with my image logging mode. I don't really need to worry about that right now. See if I can make that bigger. Sort by. I'm just going to leave that where it's at. It says sort key score. I'm going to leave that at on score, and we're going to get to see a little bit later on what that score actually means. The sort order, I'm going to use that in descending, just leave it where it's at. Scroll down a little bit. We have duplicate, delete duplicates if all of these things are telling us how we want to find the products that we're looking for. And we have a number of different options that we can actually use once we get into it. We can actually tell it only to find an object if it's oriented within a certain angle. For instance, if it's exactly 180 degrees backwards, we can not find that if we don't want to tell the robot to go 180 degrees and grab it. So we can sort of filter what objects it's going to find and which ones it's not going to find. So most of the stuff in here I don't really need to mess with. Specifically, what I do need to set is my exposure time and my user frame number. When I come down here to reference position, I don't need to do that yet because we haven't set up an actual image to find. So let's go in and set up an image. First of all, I'm going to save what I do have. And then I'm going to go up here to this box that says GPM Locator Tool. This is where we actually get to train the image that we're going to try to search for and find. If I double click on that, I guess I don't have to double click. If I single click on it, I've got these options here. One of them is teach. And since we haven't taught the robot to find any images yet, I want to do a teach and see if we can teach it a good image. So when I click on teach, it actually isn't finding anything, right? Because I don't have any products on the table for it to find. So let me cancel that. I'm going to click my live camera view. And we're going to put an object on here and try to sort of center it up where the camera can see it good. We do want to try to get our object somewhat straight with the view of the camera. So I've got a live view and I can see my item down here on the table. And everything looks okay, so I'm going to stop my live view and just take a snapshot. And then I'm going to go into this teach area. And essentially, we need to tell the camera, we need to tell the robot controller what to look for. And I'm going to try just to isolate a certain part of this item that I think it might be able to find. So that's what it's looking at. I'm going to click this snap and find button and see what comes up. Apparently nothing. It didn't like that image we tried to train it on.
What if we had someone like to?
What if I try this? One thing to remember is that the camera system, the vision system that we're using here, it's not looking for an image the way we look for an image as humans. What it's doing is it's calculating light and dark pixels. So really it's just trying to find our image based on pixels. Let me see. For whatever reason, it doesn't like anything that I'm training on. It might be my exposure or my brightness. So let me save and go back to my process and see if maybe I can adjust my exposure time to get more. So now we'll try to teach it again. Snapshot. Teach. Try setting my search window and see what that does. Yes, that's plenty. So it's not finding my item. Let's try again. Not finding it. Alright, let's try a different item then. Live view. Let's try that. So that was not great because what it did was it found two of them. Because there's two Ks on that Kit Kat bar.
Focus on the icon.
At least we're making progress because now it's finding them.
See the little key? It's the whole.
Let's see if we can grab the entire cat. Snap and find. So it did, it found it. Now what we can see down here is some data that it picked up when it did this. First of all, it gave us a score of 100, which is what we want to see. That's kind of what we expect to see because it's saying how closely does the image it found resemble the image that's trained into it. Well, we're using the exact same product, right? There should be zero deviation between what it found and what is trained since this is what we trained. If we put another one on there, we'd probably see something different. Normally you'll see scores of anywhere between 95 and 100%. We can actually set a limit. This score threshold here tells us how low we can let that score go before it'll just pass that image over and not identify it as a target. 70% is probably fine for what we're doing. We might find that this image doesn't work real well. We might find that we need better lighting on this robot in order to do any of this. We have some other stuff in here. Our GE edit. I don't want to mess with that. We have some image editing tools that we can use. For instance, our mask. We can mask out some of the area on this image if we want the robot not to look at that particular space. Emphasis area. I've not ever used that one before. But we do have a couple of editing tools that we can use when we're doing this. I like to run snap and find a couple of times and make sure that it's going to continue finding the image that I have trained. Now that I have an image trained, I need to go back to my 2D process up here. We'll run a snap and find. Probably the last most important thing that we have to do right here is I need to set my reference position. We need to snap and find an object before we can set our reference position. But once I set it, it's basically giving me an offset. That offset is essentially the center point of the image that I have trained in relation to the center point of the user frame that I created. So that offset is saying from the center of your user frame, the image that you've trained is this many positive or negative X, this many positive or negative Y. We also have a reference in degrees. And that has to do with the rotation of the object. Now, when I put a different object on there and turn it slightly, we'll see that our roll down here on our data for each item that's found, we'll see that that roll changes a little bit as that item rotates. So, if I'm good with this, I've trained my image, I think the image is going to be okay and be found by the robot. I set my reference position. I then need to save and end edit. And what I'm going to do is I'm going to go back in here so that we can see the live view of the camera, because that's pretty helpful to us. Maybe not the live view. Maybe I'll go in and do a snap and find. So the image that we're finding on that Kit Kat bar, it's not really the center of the Kit Kat, is it? That's not where we would want to pick this item. If we were going to pick this up with a suction cup, that's not really the center of the object itself. Now that I have that trained, and before I move the object, I need to train my pick position, or record my pick position. So I'm actually going to, without moving the product, I'm going to go down and find what place I want to pick on this Kit Kat bar. So that's pretty good. Let me lower my Z a little bit. That should be fine. I don't want to crush it. So I had already set up a position earlier for my pick and my hover. Right now I'm going to go ahead and record the pick. And I'm going to go straight up with the Z. And I'm going to record my hover. At this point, I can start writing the program that's going to use this information. So when we create our program that's going to use all of this data that we've created, the first thing we're going to do, the first line of the program probably needs to be sending the robot to its position that it can take pictures from. So I'm going to do a point command and send my robot to that picture taking position. Then I'm going to go in and do an instruction, and under instructions we have a menu for vision. And when I go into vision, it gives me a number of instructions that go with the vision commands. I'm going to do one called run find. And once I do a run find, it gives me a choice, and what I want to select is the vision process that we have created right here. The next line of my program is going to be a vision get offset, which is essentially going to tell me what is the offset of the vision, whatever item it finds, the offset from wherever the trained item was. When I go into there, it gives me a couple of choices. The first one is I'm going to select Brandon process again, which is again the process that we created here. After that, it gives me a choice for vision register, because it's going to store this data inside of a vision register, similar to how we store data inside a position register. There are vision registers. There's several different types of registers, and vision is one of them. So I'm going to store this data inside Vision Register 1. It doesn't really matter which one I use. And then the last part of that get offset command is actually built in with a jump label. So it's asking me what label to jump to. And what it's saying is, if it finds something, it won't jump to anything. It'll just continue going in the program. But if it doesn't find any of the images that we're looking for, what we want to do is jump up a couple of lines and keep searching. So it creates a loop for it to continue searching until it sees something, essentially. So I'm going to insert a line right after my right after line 1, where I told it to go to my camera position. I'm going to insert a line and give it a label. So I insert a line. I'm going to tell it that it's label 10. And now on that get offset command, the first thing it asks me is what process we're using. The second thing it asks me is what vision register do we want to store our data in if it finds something. And the third thing is if it doesn't find something, let's jump back to label 10. After that, the next line of the program will only ever get executed if it has indeed found one of the objects it's looking for. So the next line of the project essentially needs to be go to my hover position, right? So I'm going to do a point command. And for this one, I'm going to do a continuous move. I need to tell it to go to the position register that I used earlier when I saved my hover position. And that would be position 53 in this one. So it's going to go to position register 53. Now you guys know, or you may not know, that if you go all the way to the end of your point command, you can actually select choice. And you can add on extra options on top of your normal point command. It's probably not something you guys have done very much, if at all. But when I go over there and I hit choice, I actually have an option called V offset. And if I select that, that's not the one I want. There's another one called V offset, comma, vision register, and then there's a blank vision register. That's the one I want. Because essentially what I'm doing is I'm going to offset that hover position by whatever it saved into that vision register we were using. So I used vision register 1. After that, I'm going to do a new point command, which this time will be fine, and I will do the position register that I have chosen for my pick, which is 52. And then I'm going to go over to the very end of that point command, and again I'm going to choose choice, go over to my vision offset, comma, VR, and I'm going to offset my pick position by the same thing, the vision register number 1. And then what? We're going to go back to our hover position, right? So another point command. This one can be continuous. Again, I'm going to choose my position register 53, which was my hover. And then I'm going to go over and I'm going to tell that to offset with my vision offset also. So all three of those moves are going to be offset by whatever data it found when it was searching for that image. After that, I can continue the rest of my program as normal, where I would go to some place position and set down this object. The one thing I'm not doing is turning on and off my tool, which is actually going to be just fine for this example. So here's the other thing I'm going to do. At the very end of my program and at the very beginning of my program, I'm going to create a label and a jump label so that I can loop this program over and over again and not come to the end of my program. So go over and insert a line on line 1, and I'm going to create a label . I'm going to call this label 20. And then at the very end of my program, I'm going to do a jump label. Jump to label 20. So now I should be able to run this program . And it has found an image already because we haven't moved it from the one we trained. So what we can now do is move our item and see. I wish I could speed this robot up a little bit. What if I put it over here at an angle? Now I'm going to stop the program real quick so I can show you guys something on the big screen. If I end this edit and I close out of all of this, I can go in to that main screen that we saw earlier when we first logged in, and now I can do Vision Runtime. And Vision Runtime is basically just going to give me a view of what the camera's seeing, and it's going to show me any items that it found down here in this log window. It's also going to show me what my score is, and what my X and Y offset are, and most importantly to me is probably the roll of that image that it found, because that's going to be what rotation it's finding it at. So now that we have that up on the screen, I'm going to continue running this program. So we can see really it's going back to that camera position just long enough. It keeps finding the image, which is great. It keeps going to my pick point. See right here, if you look at the screen, I've moved my item outside of the window of the camera, so it's clearly not seeing that. But we're able to hit this item over and over again, which is exactly what we had intended, right? And what's even better is now that we've verified it, I'm going to try using the suction tool on it. So I'm going to go over, insert another line right after my pick, and tell it one of my tool instructions, one of my I/O instructions. Robot output 4 equals on. And then after I go to hover, I'm just going to turn off my tool, which is going to drop it. Not how we would normally do this, but it saves us some time from creating another couple of locations. Robot output 4 equals off. So let's go up to the top and see what that does for us. Perfect.
What did you do? Supposed to drop it?
Yeah, I didn't create any picker, or I didn't create any place locations. All I did was tell it that when it got back to its hover to turn off the tool. So it's working exactly as I programmed it to. I guess this concludes the video. Thanks for watching.